On problem number 20, we are going to find all these little pieces of the graph, and maybe it's best if we start by typing this function into our calculator. So if we come over here to the calculator, what's going to happen is we're going to go to y equals, and we're going to type in the function, which I need to be able to see. So it's going to be negative, parentheses, x minus 3 squared, plus 9. So just checking here, negative. So the negative button down at the bottom of your calculator screen, and then the minus is to the right on the screen. And then we can hit graph here. And we don't really need that. What we really want are a couple of points with the table. By the way, you should be able to draw that picture without using a calculator, but I'm not taking the calculator out of your hands for this particular problem. So we need to go to the table. Second and graph gets us to the table, and we get some points here. So leaving that screen up here for a second for you to look at them, but then I'm going to move the calculator here and we're going to graph. So starting with, oh good, I can see them actually, 0, 0, 1, 5, 2, 8, 3, 9, 4, 8, 5, 5, and 6, 0. So I know it says at least 3 key points, but I like to have more, and I also like to connect my points. So here's our picture. So our turning point on this problem. Change the sign, keep the sign. But you could look over the picture and find the vertex. And that's what the turning point is. Another word for turning point is vertex. That is a high point on the graph, so it's going to be a maximum. The axis of symmetry is x equals, and remember I'm still picky about that. So what does x equal in the vertex? It equals 3. Just a reminder that the axis of symmetry is a line that goes right down the middle of the graph. It cuts the graph in half, such that if we fold the graph in half, the points on the right will land on the points on the left. The y-intercept, we can see, is 0, 0 in this case. The domain for all of our quadratics are negative infinity to infinity. Our range, we need to ask ourselves, do we have a high point or do we have a low point on the graph? We have a high point, and our high point is this point right here, our vertex or our turning point. The y value of this turning point is 9. It's negative infinity to 9. And 9 is a point on the graph, so we're going to include that. Where the graph crosses the x-axis. So it's 0, 0, and 6, 0. And finally, the transformations. The negative in front of the function means that we're going to reflect over the x-axis. Then minus 3 means that we move our graph right 3. And then plus 9 means that we move our graph up 9.